The determinant of the matrix A, B, C, D is defined to be A times D minus B times C. A times D here minus B times C here. These arrows represent the multiplications. A times D minus B times C. So let's apply this to the equation, the system 2x plus 4y equals 7, 4x minus 3y equals 2. And to apply it, a couple of things we do. First thing we do is, excuse me, we form the coefficient matrix. And this is something we've seen before. It's simply the coefficients of x in the first column, the coefficients of y in the second column. So here's your coefficient matrix. Now, let's calculate the determinant of the coefficient matrix. Don't look at what I've written here. Calculate the determinant of this matrix without looking at the results. You should have done that before I moved my hand away. You should have paused. And you end up with negative 22. 2 times negative 3, that's going to be negative 6. I didn't actually show the multiplication there. That's very straightforward. Minus 4 times 4, which is negative 16. Negative 6, negative 16 gives us negative 22. Now, having understood how we do determinant of a 2 by 2 coefficient matrix, we're going to go to Cramer's rule. In Cramer's rule, the first thing we want to do is replace the x column in this matrix with the column 7, 2. The column 7, 2 comes from here. It's the right-hand side of these two equations, the column consisting of the two values on the right-hand side. We replace the x column with this. Do this before you look at what it looks like, before you look at what I've written down. Okay? And you should have gotten 7, 4, well, 7, 2 replaces the x column, the column of the x coefficients. And the 4, negative 3 is still going to be there. Okay, we get this, and the determinant of this matrix is easily seen to be 7 times negative 3 is negative 21. 4 times 2 is 8, and we're subtracting that, so it's negative 21 minus 8, or negative 29. It follows then that x, and this is, you don't know this, I'm inserting this. It follows then that x is the determinant of this matrix divided by the determinant of the coefficient matrix. That's going to be negative 29 divided by negative 22. We get 29 over 22 for our x value. Now, can we apply the same idea to calculate the value of y? Okay, you should be able to do this. When we did it in class, everybody pretty much did it correctly. So take the pattern that you've seen for x and see what you think you would modify if you're going to do this for y. Should have paused. Anyhow, here it is. Y is going to be the determinant that we get if we replace the y column of the coefficient matrix with these numbers 7, 2. And that's going to give us this matrix. The 2, 4 stays there. The 4, negative 3 being the y coefficients is replaced by 7, 2. And the denominator is still the same. The denominator is always going to be just the coefficient matrix. So right there is our determinant. And we evaluate the determinant. 2 times 2 is 4. 7 times 4 is 28. So we have 4 minus 28. The denominator is still negative 22. Because the coefficient, the denominator is still the coefficient matrix, and its determinant was determined earlier. And then we do the arithmetic. We get 24 over 22, 12/11ths if you prefer. We can substitute this value of x and this value of y back into the first equation and into the second equation and check the equations. If we do that, we find that everything checks. 2 times this value of x added to 4 times this value of y gives us 7. And 4 times our x value and 3 times our y value gives us 2. This is a scheme of Cramer's rule.